Hello, ladies and gentlemen. Welcome to Miss Moore's car. This is Jeffrey, my baby. So let's talk about driving. And so my first question for you guys is, did you know that there are 3 different controls in a car? Some of you might not know. Some of you are still getting driven around by your parents. That is okay. But we've got our steering wheel, we have our brake pedal, and we have the accelerator, or the gas pedal.
Okay.
And so we're going to do 4 things today. And as I do those 4 things, I want you to watch my speedometer. What the heck is that? Go ahead and show him, Mr. Boykin. Speedometer is this guy right here. And I want you to watch how fast the needle goes up, how fast it moves. Let's do it.
Let's do this.
All right, so my first one. Blinker. We should have put some tunes on. All right, shall I go?
Yeah, go. Just pull out and well.
I'll wait for this guy.
Yeah.
I'll wait till after the arrow is done. All right, ladies and gentlemen, here we go.
Come to a stop. Hit it.
1 Mississippi, 2 Mississippi, 3 Mississippi, 4 Mississippi, 5 Mississippi.
How fast can you go? I'm hoping you can read the speedometer.
At the 3-second mark, I want you guys to go back and rewatch that real quick. At the 3-second mark, write down what was the speedometer at that very moment.
All right.
All right, now that you're with me again.
Let's just do it again.
Yeah, let's do it again.
Fun.
Okay, so here we go. We're gonna do another 5 seconds here. All right, let me come to a stop here. Eyes on the prize.
Swimmers, take your mark. Get set. Hit.
2, 3, 4, 5. Woo! Go around here. Skirt, skirt. Okay, so what was the difference? Like, oh, hello, ladies and gentlemen. Do you live here? What was the difference between the first time I pushed on the accelerator, the gas pedal, and the second time? What did you notice about how fast the arrow went up the first time compared to how
You got it.
how fast the arrow went up the second time? All right, what we got next?
Well, now we gotta see what the brakes do to the car.
Okay.
I hope they don't break the car.
Brakes,
You could
brake
go
the
to the
car.
right. You could go to the right after these guys do.
All right, let's do it. Let's do it.
Let's do this.
I'm gonna wait till after this car goes.
All right.
And again, I'll count to 5 seconds. Last time my counting was
Well,
not
let's
so
do
hot.
that again, and you start at 0 and when you hit it, and then do the Latin Mississippi or whatever.
Do you want me to do the fast one?
Let's do the fast one again.
Fast
Come on.
Oh wait, let me.
You're good. They're not gonna catch you.
Okay, here we go.
Stop. Okay, watch that speedometer.
Ready, set, go. 1 Mississippi, 2 Mississippi, 3 Mississippi, 4 oh shit, there's a cop. Shoot, there's a cop.
Hi, officer.
Everything's
this is all
fine.
we're doing physics over here.
Oh my god. Well, dang, that kind of screws things up for us.
Well, we have data though. We have data,
Yeah.
and all we have to do
So
is.
I can go back. He's not paying attention, and we can do the braking one,
All right.
right?
Yeah.
I think it'll be right.
Solar panels, boys and girls. In case you haven't been to Golden Valley High School lately, solar panels.
Exciting stuff. Okay, is he looking at me? All right, so for this one, I'm just gonna get going at my normal pace.
Get up to the speed limit and then put the brakes out.
All right, here we go. So speed limit's about 25, 30.
25. Oh, 35. Well,
And here we go. 1 Mississippi, 2 Mississippi, 3 Mississippi, 4 Mississippi, 5 Mississippi.
okay.
Car by me. hopefully you were paying attention to the speedometer in those 5 seconds and taking note about how slowly, fast or slow, the speedometer went down.
Yeah.
Okay, we've got one more. Where's that guy at?
The policeman, he's still back there finishing his donuts.
I wonder, should I just do it right here or should I just do it on the street?
Well, let's go ahead and do the hard braking out on the street right now.
Okay. Oh, he's gone, he just left.
Woo!
Look at him over there.
Breaking the law,
We're free!
breaking the law.
All right, here we go. I'm gonna get up to the speed. All right, we are free. Okay, here we go, here we go.
1 Mississippi, 2 Mississippi, 3 Mississippi, 4 Mississippi.
Wow!
Woohoo! Did you get that?
Good job, Ms. Moore.
Whoop whoop. All right.
All right,
So
there's got to be some physics going on here,
oh
right?
yeah, oh yeah. Well, I think I'm sweating a little bit.
It's
Woo.
a warm day today.
I wish my AC was working a little. Come on, guys. All right, that's a wrap. We're gonna
I think we
head
should park
back.
down by the room.
Yeah, I think so too.
All right, see you there.
Welcome back to the classroom, ladies and gentlemen. I am sweating from being outside. Woo! Okay. All right, so let's talk about acceleration. When a car accelerates, the needle on the speedometer moves. Acceleration is how fast the speedometer needle moves.
You can go fast or slow. We saw that.
Yeah. The needle can move up or down for acceleration. So even when we're putting on the brakes and the needle goes down, we are still actually accelerating. School's out. Acceleration is the rate of change in velocity. Now remember, we said velocity and speed are, interchangeable, but velocity has that direction component. Acceleration is the rate of change in velocity, or think about your speed. Speeding up, slowing down, and changing direction are all accelerations.
Changing direction is an acceleration.
Why? Average acceleration is the change in velocity over the time interval. So we're going to be using this equation. Write this down in your notebook. Acceleration equals the change in velocity. Now this little triangle thing, that means delta. D-E-L-T-A. And that just means the change in something. The change in velocity over the change in time. What would be the units of acceleration? So when we're driving a car, we have miles per hour, yes?
Yep.
So the velocity, remember, think about that like the speed. Miles, MI per miles per hour.
Yeah, that's
Okay.
what your speedometer was telling us in the car.
Yeah, that's what we saw on our speedometer. And then our units for time are just seconds. So for acceleration, our units are miles per hour per second. Now this is just one way to look at units. You can also talk about units as meters per second, so meters per second divided by seconds, but we'll get to that later.
Okay.
Okay, so moving right along here. Instantaneous velocity is what the speedometer in the car tells you. So these are some symbols that you are going to need to know. So well, actually, let me pause for a second. Remember when we were driving the car and I was like, look at your speedometer right now. It's at 3 seconds. Go back and look at it. So when I told you to look at the speedometer at 3 seconds, okay, look back in your notes. What was the speed? What did it say? Well, that is your instantaneous velocity. It might have said something like, maybe like 11 miles per hour.
Could have been.
It could have been. Whenever you looked at that speedometer at the 3 second mark.
You were too busy driving
I
safely
know.
to remember what it was, right?
Multitasking. Don't do that. That's what I had you to help me, right? So my instantaneous velocity is what the speedometer says at that very moment, at that 3 seconds. And we also have some other instantaneous velocities we have to think about. We call the instantaneous velocity at the start the V initial. And then we call the instantaneous velocity at the end the V final.
Sweet.
Sweet. Write it down. This is our equation for acceleration. Now, again, remember how we drew that bar over the V? What does that stand for?
I think it's average, Miss Moore.
Average acceleration. So our average acceleration equals the final velocity minus the initial velocity, all divided by the time it took us to do that. So we can actually calculate our average acceleration here. I want you to look back at your at the video, and I want you to find for the very first video that we watched. For the very first drive that we made, I want you to find the final velocity when we push the gas pedal, the accelerator slowly.
And when we got to 5 seconds, so at 5 seconds, how fast are you going?
And at the 5 second mark. So get that information down, the time, your final velocity, and your initial velocity. Okay, let's do it.
All right.
So, let's start with the time. The total time it took us, so I wanted to know what the acceleration is over 5 seconds. So at the bottom, I'm gonna put 5 seconds. Now, the final velocity, if you stop the video, that very first drive that we took, you'll see that the final velocity is somewhere around 21 miles per hour. It's not perfect. If you're like, Miss Moore, it was 20, that's fine. put 20 if you want, okay? And we're gonna subtract this from the initial velocity. Now, how did we start?
I think you were just sitting there not moving at all.
Just hanging, right? So, miles per hour here, 0 miles per hour there. And I'm just gonna go ahead and plug this in my calculator. I'm gonna put a parenthesis. I'm gonna say 21 minus 0, which is, well, nothing, divided by 5, and I'm gonna get 4.200. I'm just gonna write 4.2 equals 4.2, over here. And then what are my units? Well, I've got miles per hour on the top divided by seconds.
Cool.
Sweet, okay. So that was for the very first video that we did.
That's your average acceleration. That meant that every second that went by, you were averaging 4.2 miles an hour faster.
So after the first second, 4.2 miles. After the second, 8.4 miles. After the third second, I can't do the math anymore. Okay, here we go. I'm gonna go ahead and just put it down here. So this one is gonna be the second one we did when we slammed the accelerator. So again, it was over 5 seconds. Okay, that's why we kept that time interval the same. And if you go back and look at the video and see what the velocity was right when I said 5 seconds.
Oh, that's not the one with the cop, was it?
No, not the cop one, because we only got to 4 seconds in that video. Whoops. Good thing, or else I probably would have gotten a ticket. I would like to see myself work my way out of that one. So the one before that, and if you pause the video and you look back at what it should be, I got to about 42 miles per hour in a school zone. It's not good. Don't do that. Minus, and again, we started from rest, right? We stopped the car. We're like looking both ways for traffic. Miles per hour. All right, so calculator. And I'm not going to put the 0 in this time. I'm just going to say 42 divided by 5. I didn't need those parentheses, but here we are. 8.4. 2 hints. Miles per hour. So I see miles per hour divided by seconds. Boom. Wow, that looks really ugly. That's an H, guys. Okay. All right, so here, this is our average acceleration when I slammed my foot on the gas pedal over 5 seconds. Sorry, my average acceleration per second. So in the first second, I went 8.4 miles per hour. In the second second, I did
16.8.
16.8 miles per hour. In the third second, you keep doing the
25.2.
I'll take your word for
I'm
it.
done.
Right?
I'm out.
Tough out. And there you go. There you have it. So,
what about comparing the two?
Oh yeah, okay, so let's compare the two. When we were accelerating slowly, it was 4.2 miles per hour. When we were accelerating fast, jamming our foot on the gas pedal on the accelerator, it was 8.4 miles per hour per second. Almost double the acceleration that it was over here.
Wow.
Wow, we're going fast.
Wow, that's some acceleration.
So, I'm gonna pull this out for a second. We need to talk about this. Acceleration is a vector quantity. The direction depends on F final minus F initial. Pretend like that's a 0, guys. If the change in velocity, delta V, is positive, then acceleration is positive. If the change in velocity is negative, acceleration is negative. What does that mean?
How could acceleration be negative? Oh, would that be like when you put the brakes on?
Yes. So let's go ahead and take a look at this. Go back here. Oh, wrong way. There we go. Okay. So this top number right here reflects our velocity, the change in velocity. And we said that when the change of velocity is positive, that means our acceleration is positive. Well, 42 minus 0 is 42, right?
Yeah.
A positive 42.
Yep.
So that means that our acceleration is positive.
Sweet.
Same thing over here. 20 minus 0 is a positive 21, which means that we have a positive acceleration.
Yep.
Okay, let's go ahead and think back to, let's go ahead and look back at our video again. What if, make that look better. What if we took data from when we put the brakes on?
So I just wanted to give you guys a heads up. I totally messed up on my math when I did this for the first time around. So I used the wrong, I used 21 instead of 31. So the really good version of this video that I had originally, I had to redo. So I put this picture in here first so you could copy it down. And then as I'm explaining it, you have the work and you can just listen to my voice. I hope this helps.
So I went back and looked at our video, and I noticed that our initial velocity, so I went back to my video and I noticed that my initial velocity in the third video, the one where I gently decreased and put the brakes on, my initial velocity was 31 miles per hour. And then even though I messed up in the video, I was supposed to stop all the way. I just got a little bit nervous because there was traffic coming. So let's pretend like I stopped completely and that my speedometer read 0 miles per hour. So now when I do my math, I get negative 31 divided by 5 miles per hour seconds. And if I do that math, I get negative 31 divided by 5, and I get negative 6.2. Negative 6.2 miles per hour per second. So for every second that passes, I am accelerating in the negative direction 6.2 miles per hour. So what does this mean? Well, before we had a positive velocity up here, right? We had that positive velocity. We said delta V, if it's positive, that means our acceleration is positive. And it made sense because we have a positive velocity right here. But now our velocity, which is this number, is a negative, which means our acceleration is negative. But we can see that right there. All right.